Hey there, good to see you again. In this video, we're gonna do some really cool stuff. We're finally gonna capture ourselves that PsyDuck. So we're gonna do a whole bunch of stuff. Colliders, animations, particles. We might even use a coroutine. Who knows? It's gonna be amazing. Let's just go. So let's start with getting ourselves a target to throw our Pokeballs at. Let's put a PsyDuck in the map. So we want to go to our models, to the meshes, and grab a PsyDuck. Just drop PsyDuck in the map, and we're immediately going to turn it into a prefab. So I'm going to remove the SM part and just have a PsyDuck, and then in the prefabs folder, we can just drag and drop PsyDuck there. It's going to be an original prefab, and this is going to be our PsyDuck prefab that we will be using couple more times. Now I'm going to rotate the camera because when we start the game, our character will be rotated in that direction, and just to save time, because we're going to probably run into some issues every once in a while. Oh, why am I dragging PsyDuck here? I need to drag PsyDuck here. Yeah, I'm putting them there so that we don't have to rotate around 180 degrees every time. But yeah, 3 PsyDucks to throw some Pokeballs at and see if we can capture those. That will suffice for now. We don't have to update the names or anything. This looks fine to me. All right, so with that out of the way, how are we going to know that we've hit a PsyDuck? Now, there's a lot of options that we could use there when we're colliding, but one way to do it is to work with tags. Now, tags are a system in Unity, and I'm going to select PsyDuck here, or rather the prefab, that you can use to identify objects pretty easily, and there's some pre-made tags in there, such as the player tag, the game controller, and so forth that you can use. And we're going to make one, and we are going to So click on this, and the tag is going to be called Pokemon. I don't think for this project that we are going to have multiple Pokemon, but if you wanted to, unless they're going to behave differently, all PsyDucks are going to be Pokemon. So we go back to our PsyDuck prefab, and in here, since we made it, it should already say that it's PsyDuck tag. Oh no, wait, that's the name. Down here, that's where we need to go. Yep. So, and if I click on any of the ones in the scene now, let's see, it says tag Pokemon on all of them because we updated the prefab. So that's a convenient way of doing that. So next up, we need to add some code to whenever our Pokeball collides with PsyDuck. And since I used the word collide, I need to talk about collisions. So to put it really simply, colliders are basically the invisible boundaries of an object. We've already seen this with the capsule collider that we put on our player character, on our trainer. The trees also have colliders now, and I didn't really explain much of it at that time because we weren't really doing much with it. It's just this boundary that you can't really cross so that you run into a tree as opposed to just going through a tree. However, there's a couple more things to know about colliders when we're actually going to use them for code. So the first thing that you need to know is that colliders oftentimes interact with rigid bodies. So a rigid body, as you can see on the slide, is a component that will just control the object's position, also its rotation, through the physics system that's built into Unity. And there's 2 types of collisions that you can use in Unity that might or might not interfere or interact with that rigid body. So the first one are physics collisions. So those are the kinds of collisions that you would typically have when you run into something or if you're going to push something out of the way. And then there are trigger collisions, which are the kind of collisions where an object is oftentimes invisible and is just triggering certain actions in our codes. So the difference between both of those you can find in the isTrigger boolean on your collider, and I'll demonstrate that in a minute. But there is a variable that you will have on your collider, even the colliders that we have been using, that you can set to false if you want it to be a physics collider, and to true if you want it to be a trigger collider. So if you're looking on the slides here, it mainly comes down to if that boolean is false, we have a rigid body that will respond to collision. If it's true, we will not have the rigid body respond to collision. And as you can see, the top is usually used to prevent players from going somewhere or for game objects to stay put somewhere or at least bounce off of something. While the other one, the trigger, is mostly used to mark invisibly where the player can't really see that something needs to happen when a certain object goes somewhere or when the player goes somewhere. So that's triggers and physics colliders really. And these are very similar methods that you can use, and I will use one in just a minute, that can detect where a collision is happening between 2 game objects. So that's important to know. and I'll demonstrate that in just a second. The final point that I put on the slide is about kinematic rigid bodies. So there is an option that we will use later on, and I'll get back to it at that point, that you can make it so that your rigid body actually doesn't respond to physics anymore itself, but it will have other objects interact with it in the same way through physics. So it's an interesting thing that you can do so that you can still run into an object, but the object itself will not be pushed over, for instance. So those is just a really quick summary of colliders, and I'm going to put all of that stuff in practice. If you're not getting everything right away, that's fine. It'll all make sense as we're doing this in a minute. And with that quick overview out of the way, we can set up a collision between our Pokéball and our PsyDuck. So let's write a script for our Pokéball. So let's make a new C# script, and let's call it Pokéball controller. And actually, while we're at it, I'm going to get ahead of myself a little bit as well. And I'm going to make two more scripts. The first one is going to be, okay, thanks Unity. The first one is going to be PsyDuck controller, or maybe, let's just call it Pokemon controller. Who knows what we will be doing next. And then finally, oops, I inadvertently pressed a button I shouldn't have pressed. Show and Explorer, which is not that big of a deal. And I am going to make a script called PokeFlash controller. And I'm going to refer to the particle as the PokeFlash because it's going to be a flash effect on my Pokeball that I'm going to be making. So anyways, I'm going to double click my Pokemon controller now. But I could just as well have double clicked the Pokeball, which is actually the one that I want. And you'll see how Ryder is just opening these up neatly. And you can see them all here if you're in Explorer. Now, I do like the structure view a lot as well, if your script is getting a little bit bigger, because link player, so we can see all the stuff that we did here and all the methods that we created. Anyways, I am going on a little bit of a tangent that's completely unnecessary right now. So what do we want to do with this script here? Well, we want to have a collision set up. So in this case, we want our Pokeball to bounce off of our PsyDuck. So it's definitely not going to be a trigger, because with a trigger you would be able to go through your character. So we are going to use the collision scripts. And we're going to actually have Ryder generated, and we can just show context actions and then generate code. And then it can be a Unity event for collision. And then you can see here, you have on collision enter and 2D. And then you have exit and exit 2D and stay 2D. And you'll also find on trigger with the same options. So enter means the first time the collision happens. Exit means when the collision is no longer happening. And stay is if the collision is going on. So kind of similar to when you keep the key pressed down with the key down function. So we're going to use the one for on collision enter. And here we go. And Unity is just going to fill all this stuff in for us, which is great. We're not going to throw exceptions. Like, this is code for if something goes wrong. We don't need that right now. We're keeping stuff simple. But what we want to do is we want to check for a collision with any objects that have that tag. So I'm getting ahead of myself here because I can't type as fast as I speak. But if our tag is Pokemon, here we go, we can have our collision. So we'll do this. And what we will do is, so when this happens, when a collision enters with a collision object, if that collision object has a tag Pokemon, we're going to run the code in here. So this is the output that comes in whenever collision happens, right? And this contains a lot more information. If you hover over it and you look for the external documentation, there's a lot more stuff to it. The collision data actually contains all of these properties. You can know where the collision is exactly, where the first contact point was, and all that kind of stuff. It's super cool. But we don't need any of that stuff right now. We just want to know if the tag matches up with Pokemon, because then we know we have a hit. And what we want to do then is we want to save that object. We want to know what Pokemon that we just hit, because we're going to have multiple Pokemon. So what we're going to do is private game object, because this is not going to be a public variable because we're not going to use it anywhere else, called Pokemon. And in our collision tag, we are going to set that variable equal to the game object that comes with the collision. Like so. And when we do this, we are going to save the game object that we have as a reference down here, and we will be able to keep a hold of it. So with that, we can then start doing a whole bunch of code, and we can basically run code to have an animation play out so that the Pokeball will behave in a certain way. And for that, we are going to use some physics. So usually you can run that code in the update method, but because we're using physics, it's recommended to use another update method. In this case, it is called void fixed update. So the difference between update and fixed update, like I said, is that fixed update uses physics calculations, and we are going to mess with physics a little bit, so we're going to run it in fixed update instead. And here we can run our code. So if we have a Pokemon, so if the Pokemon, oh, I always keep forgetting these parentheses, I don't know why. If the Pokemon is not null, which it will be by default, like if you write, writer really shows you this really nicely. If you put it equals to null, it'll put it to gray because this is redundant code, because it is going to be null at the start. So that's good because it's going to be turned not null when we get in the collision. So if Pokemon is not null, then we can do something. So how about just for now we'll just do a log, and our log is going to be hit. Let's write hit in there. All right. So, and we can try it out. Now, the only thing that I want to do before we actually give it a try is we're going to write a little bit of extra code. We're going to go NN Pokemon equals to null. So why am I adding that little bit of code? Well, we don't want to capture multiple Pokemon. Like if our Pokeball hits one Pokemon and then bounces onto another, we're gonna grab the second Pokemon and replace the first Pokemon in here. Like we don't want that. The first Pokemon we hit, that's the one we're working with. So that's where we're adding a little bit of code here. So anyways, let's try this. So back in Unity, there are now two things that we need to do before this script will actually work. So what will those things be? Well, first one is we need to hook up that script to our Pokeball. The second one is for collision enter to work, we need to have a collider. So we need to hook up a collider to our PsyDuck. Our Pokeball already should have one. So let's make that happen and start with the script on the Pokeball. So I got my Pokeball up here, and I can just go into scripts and then grab the Pokeball controller and just add it to it. And now all the Pokeball that I'll throw should have a script. Then for the PsyDuck, we want to grab the PsyDuck prefab, go to scripts, and grab, well actually you can add the Pokemon controller already to it as well, so we don't have to worry about it later. And we can add a collider through, here we go, capsule collider will be just fine. And then we can add one. Now to edit the collider actually and make sure that it is where we want it to be, we want to open up the prefab itself. So just double click on your prefab and you'll see this thing. And then you can pretty easily just, there's these little handles. Oh, so if you lose your collider, click on edit collider, and that will show you these little handles that you can use to move your collider around and move the top to where you want it to be, move the bottom to where you want it to be, rotate it a little bit so that you make sure, because it can be tricky sometimes to see where your collider is at. So I'm holding down the right mouse button to move in case it's not working for you well. So like bring them over like so. And I think this is a collider that I can kind of live with, maybe a little bit more upwards, but there, like, I think that's a fine collider for now and looking from all angles. So make sure to look from all angles because it's easy to just put your collider somewhere where it shouldn't be. And then if we go back in here, all of our PsyDucks, when you select them, you'll see the collider right there. And we could have done it that way as well, like click edit collider here and then just edit it. As a quick side note, if we wanted this collider to be a trigger collider, this is that option that I was talking about earlier. So right now, if we add a rigid body to them, our collisions will work. But if we add is trigger, you can still go through PsyDuck because the rigid body will not take those types of instructions. However, at this time, I don't think we need to add a rigid body yet because that will make our PsyDucks respond to gravity and such and start wobbling over, and they're already hard enough to hit. With that in mind, let's see if the hitting actually works. Let's give it a shot, and I'm just going to fast forward here. And here we are now. So I can still toss my Pokeballs around, and yep, I got a hit. You can see it pop up here. So that collider is working. I mean, let's toss it somewhere else. Oh, well, it's going to be hard to see because it just stays hit, but like you can see on the second, oh, it's actually hitting everything. So there's still something wrong with our code because it looks like it's hitting the terrain, unless it's laying right next to a Pokemon. That could also be the case, of course. But yeah, well, all right. What we can do with that is we could just go into our code, and instead of having this thing here, if Pokemon is not null, let's do destroy Pokemon. And that will destroy the game object that is stored in that variable. So let's see what happens when we run that. All right. Well, let's see if we can clear them out. There we go. So, oh yeah, the hit's probably triggering because it's not just checking for the Pokemon, it's checking whenever. But like, yeah, so this should work. And we should be able to just remove the Pokemon by tossing Pokeballs at them. So, excellent, excellent. Let's move on. And let's get into animating, capturing the PsyDuck. Now, I've pulled up this quick YouTube video to show you what that's supposed to look like. So let's play it.
Get ready. Got him. Stay in there. You gotta stay in there. Nice.
All right, now I'm not going to do all of that because it's a lot, but we're going to go over the general principles of what's going on in there. So the first thing that I would like to do next is that Pokeball kind of bounced off. And for us, as soon as we're hitting them, they're just disappearing. So we would like to have a neat little bounce, and not just how the physics are going to bounce, and we want to give it a little bit of extra oomph, so it's going to be jumping up higher away from the Pokemon. So how do I accomplish that? Well, for starters, let's get rid of this line of code because that was just for testing. And let's grab a hold of our rigid body. And it's just going to be a private variable just for this purpose. Equals to get component, rigid body. There we go. And then we are going to immediately going to use it here to add some force. So rigid body dot add force. And well, we want the Pokeball to hit PsyDuck and then just jump upwards a little bit like in the animation. So we can just use the unit vector for up, maybe times 2 so it's a little bit more strength. And our force mode is going to be impulse like we did last time. All right, so when I fast forward this, let's see if it works. So, okay, I got to make sure I hit him. Whoa, that's a lot of more force than I anticipated. Whoa, okay. But yeah, so at least that is working. I'm just wondering, why am I seeing this much? Because this is really, really, really a lot of force all of a sudden that's coming off of my Pokemon. Oh yeah, of course, we are not we are doing fixed updates, so we are repeating this code over and over and over and over. So frame 1, we're doing this force at frame 2, we're doing it again and again. So it's just going to keep going up and up and up and up and get a whole bunch of force. So I think that means we're ready to set up some code that allows us to animate this properly. And to do that, I'm going to make a small state machine, if you will, just by implementing a switch. So a switch operation or keyword will just keep track of where the animation is going to be at certain points in time, like this. And we're going to set up an integer to keep track of this. So our first case is we're going to apply upwards force from the Pokemon we just hit. So we're going to put that in. There we go. And then we're going to break, because that's how switches work. And then next, case 1, and we're going to, no, I didn't want to write anything there, and we're going to break as well. I don't want to deal with this writer setting right now. So what I'm going to do then is I'm going to go up here, and I'm going to declare private integer. Oh, actually it's int, I believe. Yeah, int animation. Oh wait, it's case sensitive, so animation stage. There we go. So now we have an integer that will start at 0, called animation stage. And what's going to happen is once we have a Pokemon that's stored in this variable, we're going to hit this switch, and it'll see what is animation stage at. And if it's 0, it'll run this. If it's 1, it'll run this. Now, this is not going to solve our problem just yet because it's going to stay 0. So the next thing that we want to do is once we've applied a little bit a force, we want to move to animation stage 1, like so. And then you always have to put break. That's the thing with switches. After every case, you have to write break. If you don't write that, it will run this code and immediately go there, even though animation stage is not necessarily where you expect it to be. So before I test it though, I am going to write up what I want to do with this state machine that we are building now. So what we're going to do is everywhere, and when I'm done with that, this is what it looks like for me. So case 0, we're applying the force like we just already put the code in. Then we're going to check when the Pokeball has reached the apex of the curve, when it's bouncing off our Pokeball. So when the Pokeball is coming down again, we want to suspend it in thin air, like in the animation. So we're going to check for that. And then once we have reached that point, we're going to use some vectors for that. We're going to go to case 2, where we're going to hang in thin air. We're going to rotate towards the Pokemon. We're going to open the Pokeball. We're going to spawn a particle on the Pokemon, and then we're going to remove the Pokemon. So a lot of stuff happening here. And then when we figured that one out, I don't know which one we're going to be using, but one of those animations is going to then trigger the next case. We're going to close the Pokeball, rotate towards the player. Then we are going to drop to the ground. I inadvertently duplicated it here, so we're basically just dropping to the ground here, I guess. Or maybe here we're just closing. I don't know. We'll figure it out later. In case 5, we're on the ground now. We're going to stop physics entirely, and we're going to play our wiggle animation for our Pokeball. And then in case 6, we're going to decide whether the Pokemon escapes or not. So that is a full Pokeball, whatever you will, animation. So let me fast forward and see if this actually works now and that we no longer see it jump up, but it'll just go do this once and then go to stage 2. All right, let's try it out. And if everything went well, we should see this little bounce when we're, yeah, I saw it. A little bounce when we're hitting the Pokemon. Let's get a little closer. If I can get him on the top of his head, it should be a lot better to see. Oh man, why am I so bad at tossing Pokeballs? See how it got a little bit of force going upwards. So that's the effect that we want here. So at the peak of that, we now want to suspend that ball into thin air. So that will be animation stage, so stage 2 actually. So how are we going to do that? Well, we can look at the velocity, because Rigidbodies actually have a lot of different properties as well, and one of them is velocity. So velocity just tracks changes in velocity, and we're going to look at the y-axis. So if we have velocity going downwards, so then it will be a negative float, then we know that the Pokeball is not going upwards anymore. So as soon as the velocity is going lower than 0, we can go to animation stage 3. That's all there is to it. Animation stage 3. There we go. Wait, 2. Why did I write 3? So it's like, yeah, because I saw the code here, so it has to be 2. So yeah, once we are there, we can go on, and then in here we want, because we want to hang in thin air here, right? So we are going to, if you remember the kinematic, so if we set is kinematic to false, or to true rather, that will no longer have gravity applied to us. We could also just disable the gravity, but I don't know. Like, I'm going to use the kinematic thing. That made more sense to me when I was preparing this. So I'm going to use is rigid body. We already have that. Is kinematic. We're going to set that to true. So that is going to make us hang in thin air. So that's the hang in thin air part. All right. So that's a lot of stuff. Let's fast forward and see if it works. Okay, and hopefully I can hit the... I don't want to have like 5 extra minutes of me missing Pokeball. Yep, there you go. Suspended in thin air. Ready to open up and complete the animation. All right, so next up I'm going to rotate towards the Pokemon and open the Pokeball. So yeah, I think I'm going to do those two in one step and then test again. So let's start with opening the Pokeball. That means animation, and if you remember previous videos, that means animation controller in this case. So what we're going to do is we're going to create an animation controller again, and this one is going to call it AC Pokeball. All right, and then we get that here. And in here, we're going to set up our animation controller. We're going to grab, close, open, and wiggle. We're going to put those in there. Oh, connected. Yeah, I want open to be the first one. I want close to be the second one, because that's the order that we have. The Pokeball opens, the Pokeball closes, and then we get the little wiggle. And we're going to put some transitions in there. And I want these to have the exit time so that they are definitely ended before they're going to go over to the next one. And we are going to have to declare some sort of a state. So what we're going to do is we're going to do an integer for this one. And we're going to have state starting at 0 play. So we're going to set the animation between open and close on state 1. So let's go here. So when we go equal to 1 on state, we go to close. And again, it's a state machine. Equal to 2, we go to wiggle. And I don't think we're ever going to go back from wiggle and open it up again. Like, we're just going to delete the Pokeball at the end. I kind of want to keep this video as concise as I possibly can because it's going to be long. So 1, 2, that looks good to me. Now we have an animation controller. And since we have that, we probably want to hook that up to our Pokeball. So let's grab the Pokeball. So that's available in Inspector. Go to Animations. And I don't know if you can actually, like, will it make, no, it won't make the controller automatically. That's fine. Add component. Controller. Okay, animator, that's what it's called. Yeah. So grab the animator, and then we need to put the controller in there for the Pokeball. So now our Pokeball can be opened and closed, and we have a variable here that we can use to go through it. So that's all wonderful. So getting back to our script, all we really have to do now is just rotate to the player because we're already gonna open up that Pokeball because that's our first animation. So what we're gonna do is we are going to do this with quaternions right now. And I'm going to create a quaternion which is going to be called rotation towards Pokemon. So I want Unity to calculate how the Pokeball needs to be rotated to rotate towards the Pokemon. And we could calculate that ourselves, or we could just use the look rotation function. Now there's lots of other functions to accomplish the same type of thing. So all we need now is a vector from the point that we want to look at, and yeah, the difference between the point we want to look at and the point that we actually are. And that's, if we put that into look rotation, it will calculate the quaternion that will correspond to that. So all we need is the point that we want to look at. So Pokemon.transform.position minus transform position. And that will take care of that. Now, you know, there's other ways to do this as well, but I'm just want to show you how it works this way. And then all we have to do is have our rotation adjusted to it. And I want to animate this a little bit, so we're gonna use a lerp on this. So a lerp with quaternions, so it's a quaternion lerp. And lerp is basically linear interpolation. So it will interpolate between quaternion A and quaternion B, so animate a rotation. And it will do that using, well, we can't see it yet, but I'm going to do that with an interval. So what I'm going to do is I'm going to put the transform rotation in, because that's where we are. That's point A. And point B is going to be rotation towards Pokemon. And we can leave it at that, but there are overloads here as well. If I go here and press Ctrl P, no? Usually it will do that. Okay. It's not letting me see the overloads for some weird... No, it has 3 parameters. I forgot one. Okay. So the third one would be the interpolation ratio. So it's clamped between 0 and 1, and it's basically a specific point between those 2 rotations that we can set with, it's like almost like a percentage, like it's 0.5, we're going to be halfway through them. Now you can kind of use this to have some animation speed on, even though that's not really what it does. But if you put in there time, fixed delta time, because it's a physics object, I don't know if we actually need fixed delta time, but it'll work just fine. And I'm going to speed it up a little bit, times 3. So it's a pretty fast rotation because we just want it to rotate quickly. Speaking of speed, actually, I think those animations aren't fast enough for me either. If I look back at what we had here, oh, it's going to do the compiling. Well, if we're looking at the animation for opening and closing that Pokeball, yeah, I mean, I wanted to go a little bit faster than that. So to control the speed of the animation with the opening up, we can write a little bit of code. But first off, we need to know what our Pokemon or Pokeball animator is, similar to what we did with the trainer object. So what we'll do is we'll go public Pokeball animator. Yeah, well, animator. Pokeball animator. There we go. And in Unity, we need to remember to just hook up our animator to that so we have access to it. And then in here, I want to make that Pokeball animator dot. It should have a speed. Yep, there it was. Speed. I'm going to put that at 4. So that's going to play it 4 times as fast as the animation we created. And I like it better that way. So hang in thin air. This one here is rotate towards. And this one here is speed up when opening, which is handled by controller. All right, or actually rather animator. Cool, so let's fast forward and see if it works. Or actually, let's change one more thing before we do that, because I'm gonna run into an issue, because you know, when you fast forward, you can start and stop. Right now, we're immediately gonna open the Pokeball as soon as we throw it, because the animation will go straight into that. So we need to add some code to prevent that. So as soon as we start, before the first frame update even, we want to set the Pokeball animator speed to 0 so that it won't close the Pokeball or open the Pokeball immediately. So with that out of the way, we should have everything sorted out to make this work. The only thing that we still need to do is make sure that our Pokeball animator is hooked up to our Pokeball. So let's take care of that. And oh wait, it's not the one from here. It's actually the one we're using. It's just a reference. Right. So then we can press play and see how good or bad I am at hitting a Pokemon at the first try. Let's see if we can get that guy. Yeah, I mean, that looked all right. So the Pokeball's close to my hand. Oh, keep missing him. Yep, it opens up. I think I would like to increase the speed a little bit of the rotation. But aside from that, I mean, I think this is fine. Yoink. Pretty cool. Or let's leave the speed for now. It's kind of nice. So yeah, you should see... okay, hitting one more. Yoop. It's super cool. All right. Yeah, let's get back to the code. And let's look at what our next step is. Oh, it's spawning particles. Awesome. So let's make some particles, which actually starts in Unity, because we're going to click here on plus, effects, particle system. And as you can see, particles basically let us put objects in our game world that get emitted, that get spawned, a whole lot of them. And you can have really cool effects with them. I'm sure you've seen particle effects in a video game you've played at some point. You can pause, restart, stop, and when you, let's just do play. And when you make a particle system, really all that you're doing is setting a lot of variables for how they are emitted, and what their shape is, and how long they are going to be there, and if they're going to react to anything in the environment, and so forth. So all we need to do now is create something here that's going to look like a somewhat cool explosion. And I'm going to pull up a slide here, because these are the settings that I already made while I was preparing for getting a pretty cool explosion effect. So we're going to have a flash, which will have us some of the settings that will have 3 to 4 objects that are going to be emitted, that are going to live between 0.1 and 0.4 seconds. They're going to be spherical meshes, and they're going to have an emissive material on them. You can make a material and make it emissive. Just look at it as a little assignment. And then we're going to have some black dots that are going to appear as well. These are the settings that I use for that. You can put curves on them for the size over the lifespan, so that it starts really big and then gets smaller. And you'll see it, there's options for curves. The one that I want you to pick is one that looks like the Nike symbol without the hook towards the right of it. Whatever that means. And then finally, we're going to have some trials, which are going to basically going to have lines as some spheres shoot out from the middle and have a trail, like a tail, following those. So those are the settings that I want you to try to recreate. Just pause the video and see if you can make this. And as I continue, you will see me, well, I'm going to go through these, but I'm going to go through them a little bit faster then. All right. Okay, so I'm going to start with creating a folder here. Whoops, let's not mess with my PsyDuck. Creating a folder called effects. And in that folder, I'm also going to have some materials. And that's where I'm going to make 2 quick materials. So material 1 is going to be so I'm not going to put any maps on them. You could put maps on them if you want something that's going to be cooler, but I'm just going to make a color. I'm going to make it very reflective, and I'm going to put an emission on there. So again, just something, yeah, that is just global illumination. So that should work just fine, but we can put a color on there too. And let's go with something really bright with super intense. Whoa, that's really intense. But yeah, that's going to be like a bluish emissive material. So yeah, that's fine. And I'm going to call this material Pokeflash emissive, and I'm gonna misspell emissive a lot. And then I'm gonna make another one. I was thinking of duplicating it, but I'm not. I'm gonna make one. I made Pokeflash non-emissive. This is gonna be for some black dots that you're gonna see. So we're gonna have a base map that's just basically gonna be black, and I want this to be completely flat almost, maybe a little bit. Doesn't matter, like so. So those are the two materials that we're going to be using for the particle system. So with that all set up, I can start to do all the other settings. So let's see, general duration was going to be 1. We were going to stop the looping. So if I want to see it now, I just have to press stop, and then I can press play, and it will happen. And you'll see how many will actually come out instead of having a consistent loop. So then lifetime is going to be between 2 constants, so random between 2 constants. The first one 1.1, 0.4. Then we have a start speed of 0, and we're going to have a start size between components as well. So, you know, and this is just basically the original size of the spheres that we're going to get. Speaking of which, let's get to the renderer here, and we are going to render meshes instead of billboards. Billboards are just 2D images, and instead of a cube, we're going to have a sphere, which you can find here. There you go. And that should come with a material. And this is just a default Unity material, but what we're going to do is we're going to go in here and grab our emissive material. So that's everything I need to do in renderer, and then in emission going up here. So this is how the emission. So emission doesn't mean the brightness of the emitted material. It just means how many of these items we're going to be emitting. So we are going to set the rate over time to 0 because we're not going to emit more over time, but we are going to have a burst at the beginning of 5 of them. And with that all being done, we can move on to shape. So in shape, we're also going to go with a sphere shape. Not too important right now. And then the final one is I want them to have their size change over the lifetime. So just hook that up, and here's the one with the Nike symbol without the thing. So starting big, ending less big. So when we play this particle, yes, that's what I want. Like bam. Now you determine the emission and the brightness, but this is quite intense. All right, so I'm gonna call this one our Pokeflash. And this is going to be the parent one because we're going to make a couple more. But first, let's duplicate Pokeflash. Wow, so bright. And now we're going to make some black dots to appear. And the black dots are going to have pretty much everything the same, but with a couple of changes. The lifetime, the black dots, I want around a little bit longer. Start speed still the same. They are going to be a little bit smaller though. So 2 to 3 instead of 2 to 4. The renderer thing is exactly the same, except this time we are rendering a non-emissive material, so we can drop that in there. A non-emissive material, so we're gonna drop. Okay, I'm just repeating myself. It's not that your video is stuck or something. For the emission, I think that is mostly the same. We're doing burst. The shape, we're gonna mess with the radius of the shape. So, and you know, this is something that you can really just mess around with as much as you like yourself. Like, to, you know, if you want to make it. So this is the shape in which the emission is going to happen, really. That's what shape means. And then size over lifetime, and I'm doing anything different? Nope, doing the exact same thing. So when we play this, we get these black spots. And actually, I don't like the metallicness of it, so let's get rid of that. So completely, oh wow, completely like this, so it really feels like something flashing in front of your eyes. So yeah, that looks great. Awesome, awesome, awesome. So then finally, we're going to do another copy paste, and now we're going to add the trails. All right, which is also going to be a child of the one. And let's see, for general, I'm just looking at my own slide right now. For general, this will all look the same, except we now go for a starting lifetime of not that small. Oh, not that small. Okay, it's 0.4. So this is how long they'll be alive. But we want them to shoot out to the side so that we can have nice lines. So we're going to give them a start speed of 36 and a start size of 0.1 to 0.2. And honestly, creating particles is just stupid fun. It's so fun. Again, the emissive material comes out for this. And you know, you can make another one if you like. I mean, it'd be really cool when people submit this project that there would be different varieties in this. Like, you can just have fun with it. Let's see, we're emitting 5 for this one as well. I think we were doing more. Like, yeah, 15 was what I had. Rate over time still at 0. Because if you increase the rate over time, it's just going to do multiple bursts. And then we're going to add trails. That's the only other thing that I think is different. So let's add the trails. Open that one up. And our mode is going to be particles. But we're going to have a lifetime of 0.3. 0.3. And we also need to add a width over trail. So it starts less wide than how it ends, I think was what I was going to do. So the width over trail, where is the dang thing? Here we go. We can set this to a curve as well. And then we can click it. And we can not do the Nike, but we're going to rotate it 180 degrees. So if we rotate that, that would be this one. No, actually, oh, geez. This is the one that I wanted, I think, right? Yeah, I did a quick verification, and this is the one that I wanted. That looks good. So the only thing is we need a trail material because the emitting is still a sphere, but we're going to draw a trail that follows the sphere now. So we need to set the material for that. And there's a new value now here. So that could be emissive as well. I think that would look good. All right. So with all that, let's see what that looks like. Yeah. Look at them go. So we're going to make these children of the Pokeflash. And now when we play Pokeflash, it's going to play all of them. And this is the effect that I want for the Pokemon to be captured. Looks cool. Looks very, very cool, actually. So the final thing I'm going to do is I'm going to go to the effects folder and make a prefab of it so that we can easily spawn it. And then we can delete it here. And now we have a particle that we can instantiate. So let's take care of that. Now, as we are instantiating this particle system, we want to be careful that case 2 is going to run for a while with the animations and everything. I think we're going to move to the next stage as soon as our Pokeball has opened entirely. So we don't want to have the particle system loop the entire time. So what I'm going to do is I'm going to set up a variable to take care of that I'm going to call did once. So if did once hasn't been done yet, so did once, we're going to do something. And I'll declare it at the top as a private. So let's go up here and just have a private boolean. Or bool rather, called did once. And this is just going to be used, and it's going to start false, but it's just going to be used for this kind of purpose when we want to do something once while other stuff is still going on. So we're going to instantiate, and this time we're not going to save it into a variable. I'm going to show you how you can do that differently. And we're going to, oh, actually I forgot. We need a variable for our particle system as well. So let's go up here and make a public one called particle system, and this one is going to be called Pokeball PF. And I'm immediately going to go back to Unity and take care of that. There's going to be some errors here, but I don't care about that right now. So what actually I do care because this is not going to show up as long as that error is there. So let's get rid of the instantiate thing, and that should take our error away. All right. We're compiling or assembling or whatever you want to call it. Now we don't have an error, and now it should be visible in the script. So if we go to our prefab now for our Pokeball, there should be room for a particle system there. So then we can go to effects, plug the Pokeflash in there, and now that's hooked up, and we can continue. So what I want to do is I want to instantiate a Pokeflash PF prefab, which is similar like what we did with the Pokeball earlier, and that's interesting. Cannot resolve. Didn't I call it Pokeball? Okay, it needs to be Pokeflash BF. Pokeflash BF. All right. And yeah, so we're gonna make an instance of that, and we're gonna put it where our Pokemon was at. So Pokemon transform dot position, lovely. And the orientation, we can just orient it straight up, like just put it in there. So we can use quaternion identity for that. Voila. And once we've done that, we want to set did once to true, so that this triggers only once. So it's going to be false at the beginning. We're going to get in case 2. And then it's going to see that it's false. It's going to run this, going to set the true. And the next time we get to case 2, it's not going to run this again. So that's great. This should just throw one version of the particle system. And once we've done that, we can remove the Pokemon. I think that's the last bit that we had in there. Yep, remove the Pokemon. So to remove a Pokemon, usually we use destroy. But we're not going to use destroy here because if the Pokemon breaks out, I just want it to reappear. So what we can do is we can use Pokemon dot set active, like so, and set that to false. And that's the same as deactivating the Pokemon in your editor by clicking the little eyelash icon in front of it. So the final thing that we just need to know then is when do we continue and how does that work? So how do we actually get to animation stage 3? So to do that, we're gonna have to see whether our code has finished for opening or closing the Pokeball, because that's when I would like to do this. And unfortunately, Unity is really annoying about this. Like, I've worked in game engines where they made this so much easier, and I really had to look up a lot of code to find something that would work for this. So what you can do is you get your animator, and then you get the current animator state info, which will look at the layers, because there's multiple layers that you can put in your animation controller. We're not going to worry about that and just use the first one, which is layer 0. And then we pick normalized time, which is basically, so normalized time will be 0 when you haven't played the animation yet. It will turn 1 at the end of the first loop. And then it will go from 1 to 2, the second loop, 2 to 3, the third loop, and so forth. So it will be a float between 0 and 1, or between the integers, really. It will show you the percentage that it's completed. So it's halfway through its first loop, it will be 0.5. So that's what it does. So what we can do is, when this turns larger than 1.0f, it's a float, we can move on, right? Now, there's one other thing that you want to make sure you do here. It's a good idea to make sure whenever you're checking an animation for moving on, that you check that it's the correct animation, because if for some reason we go from this into the next animation faster than we anticipate, we're going to run into bugs. So we can copy this entire thing again, and we're going to get the name. We're going to just check the name, and the functions here are very limited. There's no get name type of thing. So what we're going to use is the isName function, and we can just check if the name is, and I believe it's an Pokeball open. Make sure you get your uppercase letters correctly, because otherwise this is never going to work. All right. Whew. So that is a lot of code, but yeah. So this will check that we have played, that the Pokeball is completely open, or that at least has went through that animation once. We're not ever going to get more because I think loop is turned off anyways. And then we're going to check if the name was correctly. And if all that is the case, we can go to animation stage 3. And in here, we're just going to do a quick log. Ah, jeez. Okay. We can just do a quick log. Just say hi. We're here now. All right, so this is the code for moving on that we have. And this is everything that we wanted to do here. So this is the biggest of them all. It's quite a bit of work. So yeah, we've got all of this stuff sorted out. Now there's one more thing that I want to do, because whenever you create an instance, you want to make sure you clean it up. Because if you don't clean it up, it's going to just make more and more and more of them, and this is just going to fill up. It's a big memory leak. We don't want that. Now, for this one, what I'm going to do is I'm going to go to that Pokeflash prefab, make sure it's in the inspector. And we are going to go to one of those scripts we made called Pokeflash controller, and we're just going to drop it in here. And we're going to put a little bit of code on that script as well. So I'm going to go back to writer, PokeFlash controller. And in here, just as we start, what we are going to do is we're going to run a destroy on this game object. So destroy game object. So game object is a reference to the game object itself. And then destroy, you can just destroy it or you can put a delay on it. We're going to put a delay on it. 2 seconds will do. I mean, we could look for what exactly the time would be through code for it, but like it's never longer than 2 seconds, so who cares? This is way faster and more optimal to just do it right now. So yeah, let's hook up our particle system to the prefab and let's see if everything works. So PokéFlash VFX, grab this, drop it in there, press play, and hopefully this will get everything working from the first try. So let's hook up. Let's try to line up rather. My oh my, that looks really, really cool. So yeah, I think that did everything it needed to do, right? Boink. Oh man, that looks super cool. All right, yeah, so let's move to the next stage and let's close ourselves a Pokéball. So, I mean, this is code that's all pretty straightforward, I think, with what we've already done. So first of all, closing it, so Pokéball animator dot set integer, and I call it state. So state, and our state is now going to value 1. So that's great. And we can use the same method to move down the line again. So let's use this, but instead, so I can delete this. So now we're going to animation stage 4. And here we want to set this to close. So if we would not have this code in there with the name, like we could run straight through all of these if the stars align correctly, right? So yeah, but this is pretty much what we want, and that should get us into stage 4 immediately. Now I'm not gonna I'm not gonna do much with that right now. I'm just gonna go straight to coding this thing here. So we want to rotate to the player and drop to the ground after that. So I'm gonna do rotating. Let's do coturning. Nah, let's do something else this time. Let's do transform. So this is the transform of our game object, and you'll see that there is a look at function in there as well. Now we could have done, just to make sure that people are getting this, like we could have done this thing exactly again, but look at is another way of doing this. So we're gonna look at the trainer. Oh, geez, the trainer. Yeah, why? Okay, so transform, look at, oh, because I haven't declared the trainer probably in the script yet. Yeah, so, all right, let's make sure that we know who our trainer is. So public, let's see, game object, trainer. Let's hook that up. Or actually, you know what? Let me do it differently this time as well. Instead of doing this, let's do it private. And you're gonna be like, how are we gonna tell it where the trainer is? Well, we're just gonna have it find the trailer for this specific exercise. So our trainer variable is going to be, and we're gonna use the game object find function. So the find function of the game object class. And we could use a tag similar to what we've done earlier, but for this one, I'm just going to use a name because it's more convenient. Tag, I think, is more memory optimized. I mean, who knows? I think it is, but in this case, we're going to work with that. And what I'm going to do as well, I'm kind of getting ahead of myself here a little bit, but I am going to find that trainer, right? And then I'm going to grab the transform of the trainer, and I'm going to find again to grab camera focus. And if you remember our earlier videos, our camera is looking at this specific point, because otherwise, if we're going to grab the, oh, we do want it to be a transform, not a game object. I think that's going to be easier. Yeah. So let's make it a transform instead of a game object, because I got an error for that. Because we just want to know the point really that we want to look at. We don't need the actual entire trainer object. So trainer, and so yeah, we're going to find our trainer, and the trainer has a child object called camera focus. So through transform find, we're going to look within trainer to find camera focus and get that object instead of literally the trainer, which is going to be better. So now we can look at our trainer, and let's see for look at, oh geez, what was it? Well, let's just look at the overload. So I'm putting my cursor there, pressing Ctrl P to see the overloads, and we need the world up vector. So that's fine. we can easily get that. Let's just use vector 3 dot up. That should work. And so this will rotate towards the player, which is neat. And to drop to the ground, we can just set is kinematic to false again. So let's grab rigid body dot is kinematic equals to false. There we go. So that should have us drop on the ground again. And yeah, like I think that's fine. I mean, it will just have us drop, not necessarily to the ground. So we'll have to do something to figure out when we're at the ground. But I wrote a whole bunch of code. So let's fast forward and see if I have any errors here. All right, so let's hit a Pokemon. Let's actually hit a Pokemon. Yep, that works. And we're rolling again. We're closed. Oh, look at that's yeah, that's not really what I want, but that's an easy fix though. Just select your trainer to do that, and you want to mess with these settings here. Like I think a step up offset of 0.1, because that's a step that you can scale just by running into it. So 0.1 should probably, oh, I didn't actually want to troll, but yeah, so now I can't do that anymore. I should still be able to have a little jump with a Pokeball. Yeah, I'm going to leave that in. I think that's cute. Let's not trip over our Pokeballs here now. All right, so yeah, so then let's get back to it. And I think getting to the next step would be when we have reached the ground so that we can turn the is kinematic on again and lay still and start doing our little wiggle. So to do that, we're going to go back to our collision script, which is down here. And we want to do something similar, but this time we want to check for when we are colliding with the terrain. So maybe let's start by getting an object for our terrain as well, which can be private. All right, cool. And we can then write some code. So if our collision is equal to, or actually, what am I doing? If the game object and the name of that game object equals to, and we could use a tag here as well, but I'm just going to go with terrain, which is less optimal, I've been told, but we just want to keep our stuff simple and not spend too much time on the video, because this is already going to be one of the longest videos that we'll be doing. So then we can grab that game object in the same way that we grabbed it earlier. So now we'll have a variable named terrain as soon as a collision happens. So what are we going to do with it? Well, where was I? Here. So when we close the Pokeball, drop to the ground, with drop to the ground, I kind of want to know where we are at. So we're going to do something similar. If our terrain is no longer null, or null, null, we are going to run some code, and we are going to go into animation stage 5. Lovely. And the only thing that I think we want to be careful with is if we hit a Pokemon, or if we not hit a Pokemon and we miss our ball, and like if we bounce our ball off the terrain into a Pokemon, we can have an issue, because it will set the rain and we will get here and we will immediately go to stage 5 and skip all of this. So what we want to do here is we want to make sure that the rain is null right before we hit the stage 5. So with that, we should have all our stuff that we want to easily and safely go into stage 5, where we want to stop our kinematics again, or well, actually enable kinematic again. So that will make us stop here. And yeah, like, let me fast forward and see if it works. All right, let's toss a Pokeball. And I missed it. Wonderful. Yep, that worked. So it's no longer rolling like it used to do because of the stage that it's in now. So that's all looking very predictable and exactly the way that I wanted it. So that's great. And with that, we can then get into writing some additional code for the animator. Set integer, state was the name, state, and we're going to state 2 now, I believe, unless I'm mistaken. And our Pokeball animator speed also needs to be updated here. So let's set the speed for the wiggle to 1.5. So it's a little bit faster. Now, unfortunately, when we put that wiggle together, if I remember correctly, so let me pull that up here. It's a continuous wiggle animation that we have. It's just going to keep going like that. So, and if we look at our states that we have here, there's no way to escape that. So what do we do with that? Well, writing code that will put a pause in there is doable, but it is a lot of hassle. It would be a lot easier if our animator could give us a code with some empty space at the end, right? Or an animation with some empty space at the end. So Unity actually lets us do that ourselves. You don't need to be an animator to do this. A programmer could do this as well. So I double clicked on the wiggle animation, and that brings up the dope sheet, which looks like this. There you go. And that's all the keyframes for the animation. You can see it's basically just doing this one rotation thing. And we can even see it as a curve. So this is actually the rotation of our animation. And we can edit this, you know, if you wanted to a little bit different, like we can make adjustments to it. So that's cool. So what we would want is some dead space at the end. So all you have to do is roll your middle mouse wheel and you'll get extra space. Now, what we first need to have is we want to, because if you look at the animation, if you remember that from the video, at the end, we didn't want to have the default resting animation twice. So we cut one animation, and for this, we're going to need that animation back. So we're going to press Ctrl-C up here. And actually, let me just, in case it's helpful, turn on the keyboard overlay. So I'm pressing Ctrl-C, and then I'm going to go, and actually you can set that here. Make sure it's set to frames. I'm going to go to the next frame, press Ctrl-V, and that will copy all of those. And then we just want to go as far as we have to. I'm struggling a little bit with seeing where my... here. Oh my goodness. Okay. So yeah, I'm going to go... I don't know. Let's zoom out a little bit further. Give it some time. Like this is 18, so 36 would be... like maybe 72, something like that. All right, and then I'm gonna open up my curves right here and see what's going on, because this is where our animation stopped, and then it does this entire thing out of the blue, and that's something that's very common in a game editor. So I always check my curves before I test anything, because it's a waste of time otherwise. So what we want is, we want a straight line. We want nothing to change. So to accommodate that, what we want to do is we want to click and look at the dope sheet again, which is the correct one. It's this one that we are actually editing. So this is the curve we need to edit, because otherwise it'll show you all the curves and it'll get really confusing. You can click on here, and then you can move these Bezier handles to move it around. Now, if you right click it here, you can go flat, and that will make it completely flat. And we can do that on the other side as well. So if you don't make these changes, and be very careful not to inadvertently move them, because it's easy to do. So moved it about a bit, now making it flat again. There you go. You're going to see weird rotations, but now we'll have a wiggle, and then it'll have a pause, and we can make it longer and shorter as we like by moving these about. But yeah, we just animated a Pokeball in Unity, because when we press play now, we get one wiggle, and then there's a pause. So that's great, because that's really what we want, because if we're looking at our code here, there's nothing here that is going to pause it in any kind of way. It'll just run its animation, and it'll just keep going nicely, and we'll just stay in here with the rigid body. So let's see what that looks like, and let's fast forward here. All right, I already missed one Pokeball, so let's hope I hit this one. And I missed it again. Oh gosh. It's a lot easier to do when you're not playing it on a tiny monitor. Like, it's not that I'm completely bad at video games. I'm actually pretty decent at them, but here we go. And as you can see, if we go up to the ball, it's doing that little wiggle, and it'll just keep wiggling. Wonderful. So now we're getting close to the end. All we need now is some code so that we can have our Pokemon escape, and yeah, that'll be it for this one. So let's start that by actually having our Pokemon move on and escape. So what we're going to do is we're going to grab this bit of code from up here, and actually, let me quickly turn off the keyboard thingy again, because it's probably going to get in the way of what you're looking at. And let's just paste that here. So here, what we want is we want wiggle to move on, and we want 3 loops. And after 3 loops, we're going to the final stage. And yeah, I think we don't need to do anything with the terrain anymore. That'd be kind of silly. And when we go to the final stage, we want to stop the wiggling. So it probably would be a good time here already to stop the wiggling. So let's do that. And actually, I like to put the animation stage move at the very end. Not that that really matters because this all happens in the same frame anyway, but just it's helpful for my brain. All right, so then in here, almost at the end, what we are going to do is we're gonna instantiate a Pokeflash because it's gonna come out again. So actually, let me just copy paste it because it's gonna be slightly faster. I hope. And we're gonna have to do the did once thing again, because otherwise it's gonna just keep doing that. So with that in mind though, we also need to make sure that did once goes back to false, because otherwise it won't work. So we can do that up here, right here. Let's set did once to false again, so that we can actually run this thing. So because it will be false, it will come in, it will run this one and one time, and this should be good. And after we have done that, I think we don't need our Pokeball anymore. So we're gonna destroy our game object. No delays this time. And we're gonna release our Pokemon. So Pokemon set active true. And that's why we never destroyed the Pokemon, because now we have it again. So let's say, so this will make our Pokemon escape every time if everything goes well. So let's try that out real briefly. All right, here we go. Tossing. 3 wiggles and escape. There we go. Awesome. Boy, oh boy. All right. So next up, we just need some code that is going to see if our Pokemon's going to escape or not. So what kind of code do we need for that? All right. So I'm going to put it in here so that as soon as we go into stage 6, we know if we're escaping or not, and we can just quickly see if we are escaped or not. So actually, yeah, let's already set that up. So if escaped, then we do all this. Oh, okay, sorry about that. All right, back where I was. Escaped, we're gonna do all of this stuff. And, oh geez, okay. Did I put it correctly now? No, it's probably because escape doesn't exist yet. I'll take care of that in a second. So if we are not escaping, else we'll do that, and we're gonna do other stuff. Actually, if we're not escaping, all we have to do is destroy the Pokemon, because the Pokemon is set to inactive. So at that point, we just need to get rid of our Pokemon, and we do want to make sure that our break is at the end of this. So yeah, so then we just need a variable for escaped. So we can go up here, and that's going to be a private bool escaped. There we go. And hopefully that turns my red text into, yep, okay. So I think that is pretty much all the code that we're going to use here anyways, because we're destroying, like, this is our entire animation. So we just need to figure out up here if we're escaping or not. So how do we figure that out? Well, we need some random numbers. So we're going to declare a private float R, which is just going to be a random number. And I'm going to use random. However, there are multiple options here. System, just C#, I think, is system, has a random function. Unity Mathematics has a random function. And Unity Engine has a random function. So there are all these different options for random. What you need depends on your purpose. What I would like is random range, which is a very often used function in Unity Engine. So I'm going to grab that one. And then type range. And then go 1, 10. So a 1 in 10 chance seems good for me. Now, I'm going to scroll up here really quickly, because the selection that we made determines what writer writes here. So random, because this is basically declaring a class locally to our Pokeball controller that is associated with a previously defined class. So random now means Unity Engine random, not system random or whatever the other random was. So just keep that in mind. If that code's not up there because you're not working with writer or whatever, you're going to have to write it because it's not going to work. All right, so anyways, float R. And if R equal to 1, then let's see, then we're escaping. Yep, then escaping is true. Here we go. Which means that our Pokeball animator speed can go to 0. because we no longer want to wiggle. And actually, I already wrote all this code, didn't I? Somewhere. Well, yeah, I'm kind of duplicating it now, but because I'm getting no, it needs to come in twice. It needs to come in twice. Yeah, that's why I'm doing this. So animation stage is 6 because this is another exit. So yeah, that's why we need to code both here and both there for the escape plan. So yeah, if we're doing this like so, I'm just cleaning this up real briefly. Or let's just leave space in there. So we're going to get a random number between 1 and 10. If it's 1, we are moving forward and we're getting out of here. Now, there is only one issue with this. This is not going to wait for our animation. This is just going to run every frame. So let's say for 3 seconds, if you have 24 frames per second, and it might not be 3 seconds, but 24 frames per second, that's like 72 frames in 3 seconds, right? Like that's a lot of times that this is going to run, and if it's probably going to happen every time that our Pokemon's going to escape. So we don't want this to run 72 times. We want to run this like maybe 4 times would be reasonable, like 4 D10 rolls, and if one of them hits a 1, like we're moving on. Like I think that's fine odds. Like we can do that. I'm not going to calculate them exactly, but what we need here is we need to control how often this runs outside of this. And there are multiple options to do this in Unity, and I prepared a slide for one of these options because I want to install a coroutine here. So a coroutine is basically a method that you put in your class that allows you to spread tasks over several frames as opposed to having every task having every frame. So this is something that you can use for delays, but also when you just want to have tasks happen kind of out of the regular routine that we have, out of the regular basing that we have with the frames that we are using on our main execution. However, I do need to point out there, which is the third point, this is not creating another thread of execution paths. So this is best used with long asynchronous operations, and you can see an example there where on the left side, when the key down is pressed on F, and this comes from the Unity manual, we're going to start a coroutine called fade. So then on the right, you see how a coroutine is set up. It's with an interface for an enumerator. Like, I looked into a little bit. I feel it's too complicated to explain. You just need to know, like, this is how you write a coroutine in Unity. Because you'll see it in a lot of examples if you're looking for help and documentation online because you want to implement something that wasn't explained to you through this tutorial series. But you write it like that, enumerator, and then the function name. And then the color bit is not relevant. The 4-bit is not relevant either. It's just some code that will gently change the color of a material, but what is important is the yield, return, new, wait for seconds, and then a certain amount of seconds that you put in there. So the amount of seconds that you put in there will put a delay that will run the code so that you can kind of fade the material gently in this case, or what we're going to do that we can wait a couple of seconds before we roll another D10 basically to see if our Pokemon's escaping. Now, this is a fairly, as you can see, cumbersome way to implement this. There are other ways to do this. For instance, you could use time delta time and just set a variable at a frame and then just go time delta time, adding it to another variable. And if time delta time is going over a certain number, you know that you have waited a certain amount of time. So then you can say, all right, now we can execute something. So that's one way of doing it. Another one is invoke, which you can look up in the Unity manual, which is basically, from what I've been told, a coroutine, but it's just a little bit easier or cleaner code to use than using all this. But because so many examples online are using coroutines, I wanted to use a coroutine for this one so that you'd be aware what this thing actually is. So let's get to it. So first off, you want to be careful that you don't re-trigger your coroutine over and over because it's not going to work. So we need to set up a little value like we did with did once, really. And I'm going to call it check for escape. And the sole purpose of this Boolean is just making sure that we don't run our coroutine multiple times every frame again, because that would really defeat its purpose. So we're going to only run this code if check for escape is true. And when check for escape is true, we're gonna do all of this stuff and put it in there. So carefully making sure I select everything correctly and then pasting it in there. So, and I think, yeah, I want to check for escape. I want it to be true at the beginning. So let's set it to true. I forgot that part. All right. So, yes. So I've got all that stuff. So finally, what we can do to get that delay is we are going to start that coroutine. And in the coroutine, we are going to set check for escape back to true. Because, well, sorry, I'm getting ahead of myself. Check for escape is going to become false after we run that code, similar to what we were doing with the do once for the instantiation of the particle system. So this will run this code only once, and if we roll a 1, we'll move on, and otherwise it will never run again. However, we are going to start that coroutine now. So start coroutine. And in the method for the coroutine, which we are going to call wait for check, it's just the name that we're going to give it. And we're going to wait 1 second. So we're going to run this 1 second, every 1 second. And in wait for check, we're just going to wait that 1 second. And then we're going to set check for escape to true again. So down here at the very bottom, we're going to set up our coroutine. So if you remember from the example that we just looked at, it is interface enumerator, like so. And then the name that we assigned it. So in this case, it's wait for check. And we are going to accept a float called seconds as our input. And then we are going to write the code that we had there, yield, return new, wait for seconds. Now, wait for seconds is a built-in function. And we're going to feed seconds to it. And once that has passed, we can set check for escape to true again. So again, all this does really is we start our coroutine. It will go in here, and this will run separately from our main thing. And this will run this code, wait here until the seconds have passed, and then it will do whatever we put after it, which will enable this again, and we will have another check. So with all this in there, just going to clean this up a little bit. I think we should be in good shape for all of this stuff to actually work. Just a little semicolon right here behind animation stage, which I forgot. And yeah, then we should be able to... Oh, it looks like I might have... Well, let it compile. No, it's compiling. Okay, so let's press play, and hopefully nothing too weird happens right now, and we are able to capture a Pokémon. Let's toss a ball. It's wiggling. It's wiggling. I think we got our first Pokemon. All right, wonderful. Now also pay attention while we are doing this down here that there is nothing appearing here that looks off. For instance, you know, additional Poké Flash or particle systems. So, oh gosh, is that gonna hit? No, that would have been so cool. You can play Poké Billiard now. All right, so yep, that one escaped. All right, so we have one that escaped, one that didn't escape. Let's just toss some Pokeball at the rest now. Here we go. How many do we get? Like, I mean, yeah, like about half of them came through. I think I'm satisfied with that. I think I'm happy with this. Like, oh boy, this looks cool. Now, just for the test, the sake of testing, can we still do it if we hit one? Yeah. All right, let's see if that guy has escaped or not. And I'm gonna toss it at this guy as well. Still wiggling that one. All right. We caught our PsyDucks, people. How cool is this? This is so cool. I'm just gonna tell it straight up. So yeah, no, that's super cool. Man, it's a simple game, but this is starting to look pretty fun. So yeah, that's it for this video. This was a long video. Thanks for sticking with it, but I felt like cutting this up in multiple shorter videos wasn't really gonna be super helpful anyways. So this is just the way I decided to do it. I hope you enjoyed it. I hope it's super helpful. The next video, I think PsyDuck is going to start to have to run away from us now. Exciting. All right, I'll see you there. Bye-bye.